Now, a couple of announcements. First thing is that the quiz number 2 is due tomorrow, 10 o'clock UK time. So if you haven't done quiz 2, can you please submit it using Blackboard? All right, so it's 10 o'clock UK time tomorrow, which is a Thursday, 25th of February. All right. And the second thing is about the feedback form. The feedback form closes on Friday. So if you haven't completed the feedback form, could you please complete it ASAP? I would be really grateful for your comments, whether it's positive or negative. I would be most grateful. Okay, guys. Right. So let's begin with the tutorial today. So let me share the screen. The tutorial today is this sheet here. This is the tutorial sheet for today. I hope you can see it. So I will go, as usual, I will go through line by line. I will go through every single line, okay, and I will show you what they actually mean, etc. And also at the very end of the sheet, you should look over here. There are 3 exercises that we need to do. So I will show you how to do them if I have time. All right. Okay, let's begin. Now, if you have questions, guys, just use the chat room. Okay, I will answer them as soon as possible or as quickly as possible. So you open R. I'm sure you know how to open R, right? Okay, and the first thing I'm going to talk about in this tutorial is about the rep command. The rep stands for repetition. Repetition. I hope this is the correct spelling. Not good in English. All right, so let's suppose you have a vector with these numbers 3, 22, 5, and 7, right? Then if you say rep in brackets x times 2, what you see is this. You see the vector x is repeated 2 times. So you have in the output you have 322, 5, 7, 322, 5, 7. And if you say times 3, it's repeated 3 times. So you have 322, 5, 7, 322, 5, 7, and 322, 5, 7, right? So rep is basically a repetition command. It's very useful sometimes, right? Okay, now you can also repeat it like, suppose you write like this. Now what here, here the rep, what the rep will do is it will repeat the first element 1 time, the second element 2 times, the third element 2 times, and the fourth element 2 times, right? So it's a different number of replications for the different elements in the vector, right? You can also say length out equal to 8. Now the command length out means the number of things you want in the output. So here 8 means the output contains 8 numbers, right? As you can see, there are 8 numbers here, right? So 322, 5, 7, 322, 5, 7 is repeated 8 times. So suppose you change this to 9, then this will be like this: 322, 5, 7, 322, 5, 7, and 3. And if you change this to 10, it will be like this, right? 322, 5, 7, 322, 5, 7, and 322, and so on. Okay, so length out is basically a command telling you how many numbers you want to have in the output, right? Okay. Now, if you use the each command, basically it repeats every number in the vector 3 times. So you get 3, 3, 3, 22, 22, 22, and so on, right? And you can also, you can write a vector like this, like 1 column 3 is a vector that contains the numbers 1 to 3, right? So if you say 1 colon 3 times 2, then it repeats 1, 2, 3 2 times. If it is times 3, then it repeats 3 times, right? And if you say each 2, then every element is repeated 2 times, right? So 1, 1, 2, 2, 3, 3, and so on. Okay. And if you say like this, for example, times C 1 to 3, then 1 is repeated 1 time, 2 is repeated 2 times, and 3 is repeated 3 times. And rep, you can also apply rep to non-numeric things, like, for example, letters. So suppose you have a vector containing the letters A and B, right? And you want to repeat A 2 times and B 3 times, and this is what you will get. Okay, so you see A, B, 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 right? So that's the rep command. It's a very, very simple command to use, and it's very useful sometimes, right? Okay, the next thing I want to talk about is the SEQ command. SEQ stands for sequence, as you can imagine, right? Sequence. So suppose you want a sequence from, say, 2 to 8 in steps of 2, and this is what you will get. So you get the numbers 2, 4, 6, and 8. So the numbers going from 2 to 8 in steps of 2 every time, right? And if you change this to 3, you get 2, 5, 8, because 2 plus 3 is 5, plus 3 is 8. And you can also have like non-integer numbers, like, for example, 3.5. You get only 2 numbers because 2 plus 3.5 is 5.5. 5.5 plus 3.5 is outside the range. You get only numbers within the range from 2 to 8, right? Okay, right. Next, you can also have a decreasing sequence. So, for example, if you want a sequence starting from 5 to 2 and decreases by half every time, you get this. So you see 5, 4.5, 4, 3.5, and so on, right? Okay, guys. And you can also use the length out command, which I mentioned earlier. That, so suppose you want, say, a sequence from 2 to 8, length out equal to, say, 6. Now, the output here contains 6 numbers, as you can see, and these are numbers from 2 to 8. And you may notice that these numbers are equally spaced. In other words, the difference between consecutive numbers is the same. You see, 2 plus 1.2 is 3.2, plus 1.2 is 4.4, plus 1.2 is 5.6, and so on. So it's a length of vector 6, right, from 2 to 8, and the distance between consecutive numbers is the same, right? So you can, another way of, so for example, if you want 8 numbers, right, then you get this, right? Then if you want 10 numbers, you get this, and so on. Okay, you can also do it differently, like this. Suppose you have the vector z, right? And then suppose you want to go from, say, 4 to 14 along with z, and this is what you will get. Once again, here we have numbers from 4 to 14, and we have 5 numbers because z has 5 elements, right? And these 5 numbers, as you can see, they are equally spaced, right? That is, the distance or the difference between consecutive numbers is the same, because yeah, 4 plus 2.5 is 6.5, plus 2.5 is 9, and so on, right? Now, I think I mentioned this earlier. 1:4 produces the numbers 1, 2, 3, and 4. 4:1 produces the numbers 4 to 1, decreasing by 1. Right? All right, next page. In the next page, I'm going to talk about summary statistics, how to do summary statistics in R. Okay. All right. Now to do that, let me go back to the website. Here we are. Let me read this data set, Moses. You may recall this data from week 1. This is a data set that contains the times relating to something. Okay. So let me read it. Let me go back to R, paste it. So I'm going to read this data into an object called Moses. You can call it whatever you like. It doesn't need to be Moses. So it's read table, open bracket, the name of the file, and then say header. Because it has a header, I have to say header equal to true. All right, so this is the data that I just read. Okay, right. If you type names of the object that you read, then it gives you the name of the column that you just read. So, and when you do this, right, when you say Moses dollar and the name of the column, it shows the data that you just read. So if you want to call it something short, like say T, because you don't want to write the long name every time. Sorry, excuse me, what I have done. Let me call this T, right, for short, right? So T is the data that you just read, okay? Now to do summary statistics, like for example, mean, this is the mean, right? This is the median. This is the variance, so sample variance. And this is the standard deviation and so on, right? And there, another way of doing summary statistics is to use the command find number. When you use the command find number, it produces 5 numbers. It produces 5 numbers like this. The first number is the minimum, the smallest value in the data. The second is the first quartile. The third is the median. The fourth is the third quartile, and the last one is the maximum. All right, how to read the data again. All right, let me show you, madam. All right, the data was read using this command, guys. This is the command I used. Okay, let me go back. Sorry. Okay, this is the command I used to read the data, as you can see. So it's just read dot table in open quad end quad, the name of the file, and then you say comma, then you say header equal to true. That's it, right? I think I showed you this last time in week 1. You might have forgotten, right? Anyway, all right. So 5 number is one way of summarizing data. So it produces these 5 numbers. The first is the smallest, then the first quartile, then the median, the third quartile, and the maximum, right? And if you say FNS is that, then I mean you don't need to call it FNS. You can call it any other name. So FNS contains these 5 numbers. So for example, suppose you want to find the IQR. Remember, the IQR is the difference between the third quartile and the first quartile. All right, so the IQR for this data is 1.05. Okay. Now, another way of summarizing data is to use the summary command. The summary command produces 6 numbers instead of 5 numbers. And these are the minimum, the first quartile, the median, the mean, the third quartile, and the maximum. So it produces one more number compared to the 5 number command. That number is the mean. So this is the number that is in addition to the 5 number command. All right. Now, another command I like you to know is the quantile command. So suppose you want to find the quantiles of the data, say at 0, 0.25, 0.5, 0.75, and 1. Now, there are two types. I will explain them in a minute, but the type that I will use in this course is type 6. But there's another type called type 7, which I will not use in this course. Right now, if you say type 6, this is the output that you will get. Right. So the first is the 0% quantile, which is the minimum. 25th percent quantile is the first quartile. 50th percent quantile is the median. 75th percent quantile is the third quartile, and 100% quantile is the maximum, right? Okay, so the types equal to 6 corresponds to the formula that I gave you in the video and also in the in the handwritten notes, right? Okay, but there's another type which is called type 7. Type 7 gives a slightly different answers. That's because it uses a slightly different formula. In fact, if you look at the bottom of page 2 of the tutorial sheet, if you go to the very bottom of page 2, you will see the formula for type 6 and type 7. They are slightly different, but the formula that I use in the course is type 6. So I will not use type 7 in the course, okay? All right, guys. Any questions so far, guys? Just feel free to use the chat room, guys. Are you okay so far? Guys, you okay? All right. All right, the next thing I'm going to talk about is graphics, how to do graphical summary and so on. Now, suppose you want to record everything that you are doing in R, right? One way to do that is to use the command Windows record equal to true, right? And then you press enter. It'll start recording everything that you're doing, right? I'm not going to do that because it's already recording. As you can see, the computer is already recording this session. All right, now suppose you want to open a new device. To do that, you use the command dev.new open bracket, close bracket. So as you can see, I just opened a new device, it's this one. And every device I open has a number. So this device has number 2. Now, if I apply this command one more time, now I opened a third device, which is this one, and this has number 3. Right? So every device has a number associated with this. So suppose you want to plot something on this device, but not on this device. So what you need to do that, in order to do that, you just say device set 3. So when you issue this command, what it means is that everything that you're going to plot or draw or something is going to appear in this device number 3, right? And not device number 2, right? Okay. All right. That is how you set a device in R. Now, suppose you want to switch off a device, right? So for that, you say device off 3. So this will switch off. As you can see, device 3 has disappeared, right? And suppose you want to switch off device 2, then you say this. As you can see, the device 2 has disappeared, right? All right, so it's very, very easy to do. I mean, you open a device, you can set a device to draw something, and you can switch off a device and things like that. These are easy things to do, right? Okay, the next thing I'm going to do is to talk about a bar plot. Now, you may remember this poll data that I talked about in week 1. This is the data where we talked about 5 different parties: the Conservative, Labor, Liberal Democrats, UKIP, and other parties. You may recall this data set. All right, and let me replicate each of these. So let me replicate Conservative, say 369 times, Labor 314 times, Liberal Democrat 75, UKIP 118, and other 124. So this is the data that you get. Now, if you type poll, you will see the data that I just got, right? Using the rep command, right? Now, when you have categorical, I mean, what we have here is a categorical data. So for categorical data, it's always a good idea to change the type to factor, right? So, and you do that using the factor command, right? And then once you change the type to factor, you can do all kind of things like this, for example. So this is kind of a summary of the categorical data. So it tells you how many votes or how many seats each party has got. And you can also do a plot. If you type plot, this is what you get. So this is the bar plot, which I mentioned. So this each bar in this plot denotes the number of seats the party has got. So the conservative have the highest number, and the liberal Democrats have the smallest number, right? So this is a bar plot is very useful for representing categorical data, right? Okay, guys, are you okay so far? I mean, if you have any question, just feel free to use the chat box or talk to me in person, right? All right, the next thing I'm going to talk about is the time data, which I just read a few minutes ago. Now, suppose you want to draw a histogram of this data. You use the command hist. Poll, yeah. Yeah, the poll is, I've got a question from Will. Yeah, poll is basically a categorical data that I generated using the rep command, right? So I repeated these 5 different parties this many times. So 369 times for conservative, 314 for labor, and so on. Now, once you generated the data, which is artificial data, obviously, because it is a categorical data, it's a good idea to use the factor command, because I think factor applies to all the categorical data. So whenever you have a categorical data, always try to convert the data into a factor variable. And you can do that using this command here. So you say factor in brackets poll converts the data into a factor variable. Then you can use the table command to summarize the data, and the plot command to do the bar plot, which I've shown you here, right? So I hope this makes sense. If it did not, okay. All right, guys, good. All right, let's go back to the Moses time data, which is this one. And suppose you want to do a histogram, hist. So hist ft will produce, this is, as you can see, is a histogram. The y-axis is the frequency, and the x-axis give the intervals. Now, suppose you want to have the density. Remember, I think I explained in the lectures what a density is. So if you say frequency equal to false, right, the y-axis will turn into a density, and the x-axis is the same. And suppose you want to change the x-axis to your own liking, right? So the way to do that is to use the breaks command. So if you use the breaks command, the breaks tells you when to break the x-axis. So suppose you want the x-axis from say 47 to 51 in steps of 0.4. And this is what you will get. As you can see, what I have done is to define the x-axis, from 47 to 51, and each bar is of length 0.4. Every bar on the x-axis is of length 0.4. So you can customize your x-axis of the histogram using the breaks command, right? So let me try one more thing. So let's suppose you start from say 46.8 to 50.8 in steps of 0.4, and this is what you would get, right? So here the interval start from 46.8 and end at 50.8, and each rectangle has width of 0.4. All right, now, so that's a histogram. Now, the next thing I'm going to talk about is boxplot. I know I talked about this in the class. So if you use the command boxplot in brackets, the name of the data, right, this is what you will get. Okay, so you see these things. The middle line is the median, and this line here is the first quartile, and this one is the third quartile, and this one is the lower adjacent, which I explained in the class, and this is the upper adjacent. And there are two things that are missing from this diagram: are the lower fence, which is outside the plotting range, and also the upper fence, which is also outside the plotting range, right? Okay, so the plotted things are the lower adjacent, the first quartile, the median, the third quartile, and the upper adjacent. Okay, all right, so that's how you do a box plot. Now, let me show you how to deal with when you have numerical and categorical data. So for that reason, let me go back to the website. Come on, sorry, excuse me. Let me go to this data set, which is called runners. As you can see, it has two columns. The first column is p-mol, which is kind of a concentration of a chemical that is found in your body. And the second column is a group. So the runner is either successful in completing the run or not successful in completing the run. All right, so there are two levels for the group: successful or not, right? Okay, so let me read this. So copy and paste it here. So I'm going to read it as usual, right? So let me call this data runners, okay, for short. Okay, so this is the command. So if you type runners now, you see the data that I just read, right? It has two columns. Now, if you want to know the names of the columns, which you can already see, it tells you that these are the two names of the columns. The first column is p-mol, the second is group. All right. All right. Now, suppose you want to plot a box plot. So you want to do a box plot of the first column, which is p-mol, right, versus the second column, which is group. All right. And this is what you will see. You see, this is you see there are two boxes. The first box corresponds to the runners who did not complete, and the second box corresponds to the runners who did complete. And the box plot is for the p-mol. P-mol is a concentrate is a level of is a concentration of a chemical that is found in your body or something, right? So as you can see, the concentration level is higher for the runners who did not complete compared to the runners who did. And also the variability of the concentration level is higher for those runners who did not complete compared to the runners who did. Remember, the variability is represented by the length, by the width, or the, I'm not sure, I think it's the length or the width of the box, right? Okay, you know what I'm saying. The difference between the third and the first quartile, right? So here the variability is a lot higher compared to this one, right? Okay. So boxplot is very useful when you have two groups. Like here, you have two groups of runners who were successful who were not successful. So boxplot is very useful when you try to compare two groups. Right. All right. All right. The next thing is, okay. Let me. This is the original data, right? Now, as you can see, the level of concentration goes from 29 to 414. Now, suppose you want to pick a subset of the data where the concentration level is greater than, say, 100. So So, okay, and the way to do that is as follows. So you say runners high, that means runners with high concentration is a subset of the data, which is runners, where the subset corresponds to high concentration. Okay. Okay. Now, if you type, see, this is what you will get, right? So these are the runners where the level of concentration is greater than 100, right? And as you can, and if you do like a summary, now if you do the summary command, use the summary command here, right? This is what you will get. The summary command here, because the summary command that I had used earlier was for numerical variable, whereas the runners $group is not a numerical variable. In fact, if you type runners $group, you see this is a categorical variable. So the summary command for a categorical variable it gives a different output compared to a numerical variable. So in this case, the summary command tells you how many of the runners collapsed and how many of the runners were successful. So according to this output, all 7 did not complete, and none of them were successful, right? Okay, so in this case, it's useful not to have this level. It's not to have, because none of them were successful. So one way to drop the level, right, is to use the command drop levels. So drop levels basically drops the level when there are 0 frequency, right? So because you see here that there are no people, there are no runners who were successful. So we want to drop that. So now if you do the summary again, you see that all 7 runners in this group collapsed. That means they were not successful, right? So this is one way of actually dropping the levels when there is a 0 frequency corresponding to that level, right? Okay. All right, guys. Any questions so far? I hope you are following me. If you have questions, please feel free to use the chat box. Okay. All right. The last thing I want to talk about is scatter plots, right? All right. Suppose x is a vector from -5 to 5. Then if you type this, what you will get is this, right? You see what you get here is a parabola, which is the plot of x squared versus x. I'm sure all of you know this from your calculus courses, that if you plot x squared versus x, you get the parabola, right? Right, and you can use type equal to L. If you say type equal to L, you get the lines joining up, right? By the way, this is L, not to be confused with 1. I know some of you did confuse. This stands for line, right? Not 1, right? Okay. And you can also add colors. Suppose you want a different color, like green, for example. So this is what you will get. Suppose color, so every number corresponds to a different color. So color 4 is blue, color 3 is green, and so on, right? Okay. And okay, let me do the other example on the sheet. Suppose you have a vector from 0 to 5 with the length of 100. Excuse me. So these are numbers from 0 to 5, and there are 100 numbers, and they are equally spaced, right? And suppose you want to plot x squared versus x with color 2, and this is what you will get. So this is a plot of x squared versus x over the range from 0 to 5. Now suppose on top of this plot you want to plot a cubic. Now if you want to plot a cube, to do that you need to use the lines command. So the lines command of x cube versus x, say with the color of say 3, will produce this. So what you see here is the two different graphs on the same graph, on the same, plotting region. So the one in green is a cubic polynomial, and the one in red is a quadratic polynomial. And you can do more, like suppose you want the quartic, which is polynomial of order 4. This is what you will get. So now you have 3 lines on the same graph, right? So the one in blue is a quartic, the one in green is a cubic, the one in red is a quadratic. Okay. All right, so that completes the tutorial, but we have 3 exercises to do at the end. I hope we have time. Yeah, we have time. So let's start with the first exercise. So let me show you which. So if you go to the tutorial sheet, guys, the first exercise, is this one. This is the first exercise, number 1, which is relates to the simulated data set, right? So let me go to the simulated data, which is this one, right? All right, so I'm gonna read the simulated data. I've got one more question. We don't need to write the type for lines command from Pedro. Yeah, Pedro. You can use the line, the type, but it will not. Yeah, you can use type equal to L, but it will not make a difference, Pedro. So it doesn't matter. You can use the type command, but it will not make a difference. Okay. All right. Okay. Now what I'm going to do is I'm going to do exercise 1. Exercise 1. So first thing I'm going to do is I'm going to read the data. Right. So I will show you just a minute. Okay. Let me call this data SIMDAT. All right. Or you can call it whatever you want. Okay. All right. I've got a guy wants to know how to save the worksheet. To save a worksheet, you go to File. You go to the File menu, and then you see there is a place called where you say Save Workspace, and it will come up with this, and you can put the file name of what you want. Right. So it's very easy to do. You go into File, and then you choose Save Workspace. Right. Okay. Good. All right, now I have read the data, the simulated data. So if you type SIMDAT, you see the data that I just read, right? Okay, and if you say names SIMDAT, it tells you the names of the column that you just read. Now we are interested in the second column, which is this one, right? Let me call this for short. Let me call this XS, right? All right, I'm interested in the summary statistics of this column, right? So for example, the file number summary is this one. So this is the first number is the smallest data, the second is the first quartile, the third is the median, the fourth is the third quartile, and the last one is the fifth, is the maximum. So if you call this FNS for short, FNS will contain these 5 values. So IQR, the interquartile range, is, remember, is the difference between the third quartile and the first quartile. All right. So IQR for this data is 2.64777. Now, another way of summarizing data is to use the summary command. So that produces these 6 numbers. The first is the minimum, then the first quartile, then the median, then the mean, then the third quartile, and then the maximum. We can also compute the variance using this command, the standard deviation using this command, right? And suppose you want to do a box plot, you use the command boxplot, right? So this is what you will get. So you see, I think as I mentioned before, this one is the lower adjacent, this is the first quartile, this is the median, this is the third quartile, and this is the upper adjacent. As you can see, the median is not exactly halfway. Remember, if the median is exactly halfway between the first and the third quartiles, then the distribution is symmetric. If it is not, then it is skewed. So in this case, the distribution is kind of skewed, right? Okay. All right. Another way of looking at the shape of the distribution is to do the histogram. So if you type hist of xs, this is what you get. You see, you can see clearly that the distribution is not symmetric. If it is symmetric, you will see a bell shape like the normal distribution. The normal distribution is a symmetric distribution, right? But this one is clearly not, right? You can change the frequency equal to f. So if you do this, you get the y-axis on the density scale, right? And you can also change the x-axis as you want using the breaks command. I think I mentioned this before. So suppose say you want the x-axis from 6 to say 16.5 in steps of 1.5, and this is what you will get. So here the x-axis ranges from 6 to 16.5, and the width of each rectangle is 1.5, right? All right, guys. So this completes the exercise 1. Any questions on exercise 1 before I go to the next one? Are you guys okay or not? Hello, guys. Talk to me, please. Are you okay with exercise 1? Thank you. All right. The next one is exercise 2. So if you look at exercise 2 on your tutorial sheet, right? It's about the geese data. The geese is a data from the Yellowstone National Park in the United States. It has about 222 geese. So they let me show you the data. So let me go back to the website, and this is the geese data set. As you can see, it has 3 columns of data. The first one is the day. The second one is the duration of the eruption, and the third one is the interval. Right, so I'm going to copy this data. Let me, okay, excuse me. The column that I'm interested is the duration of eruptions of the geysers, right? So I copy and paste here, whether equal to true. So let me call this data. You can call it whatever you like. You can call it, let me call it geyser, right? And if you type names, geyser, it gives you the names of the 3 columns that have been read, right? The one I'm interested is the second column, which is the duration. All right, so let me call this say XD. Okay, so if you type XD now, you see this is the data that we just read, right? Now I'm interested in the summary statistics of the duration, so I use this command. So as you can see, the minimum duration is 1.7, the maximum is 5.2, the median is 4, and so on, right? The variability can be observed by typing var. So this is the sample variance of the duration, and this is the sample standard deviation of the durations. Okay. Now, if you want to do a box plot, use the command boxplot, and this is what you will get, right? So as you can see here, the boxplot is highly skewed. I mean, the median is nowhere close to being halfway between the first and the third quartiles. All right. So it's a very highly skewed distribution. And sometimes, for some data sets, the box plot is not very useful because as you can see here, the box plot only says that the distribution is skewed, is not symmetric, right? But it doesn't say anything more than that. So sometimes it's useful to do a histogram. Is more informative than a box plot. So let's see how we can do a histogram. So let's frequency equal to false, right? And this is what you see. See, this is what you see. Now let me increase the breaks, say to say 16, and this is what you see. Now this is a lot more informative than the box plot because, as you can see, it shows a bimodal shape. But you know what? Do you guys know what a mode is? I mean, mode. Let me explain what a mode is. Mode is a point where the graph reaches or reaches its maximum. I'm sure you know this, right? Don't you? Mode is just a point. If you draw something, it's a point where it reaches a maximum. As you can see here, that the histogram has two modes. There's a mode around here, and there's a mode around here. And this mode corresponds to short duration eruptions, and this mode corresponds to long duration eruptions. So what you see here is this histogram is made up of two different. It's a mixture. It's a mixture of two different distributions. One corresponding to the short duration eruptions, which is this one, and one corresponding to long duration eruptions, which is this one. Right? So it kind of the two mixed together produces this histogram. All right, guys. So and also you can change the breaks of this. I mean, at the moment the x-axis is defined by r, but if you want to change it to your own liking, you can do whatever you want. Like for example, say from 1.5 to 5.5 in steps of say 0.25, and this is what you will get. So here the x-axis goes from 1.5 to 5.5, and each bar is of width 0.25, right? If you want to change this to say 0.5, it will look like this. If you want to change this to 0.75, it will look like this, and so on. All right, so in every case you see that the histogram is a mixture of two different distributions, right? One for short durations and another for long durations. All right, so this completes exercise 2, guys. Any questions on this, guys, before I go to exercise 3? Talk to me, guys. Are you okay with exercise 2? Yeah, you sure? All right, so let's do the last exercise, which is exercise 3. Right, that corresponds to the following data set. So let me go back to the website, which is this one. So this data set is on anorexia. Anorexia is a kind of a disease, I believe. You may know better than me. As you can see, there are 4 columns of data. The first one is case. The second one is pre-weight. The third one is post-weight. And the fourth one is the treatment. There are 3 different treatments, as you can see. And what happens is that the weight of the patient is taken before and after the treatment. So this is the weight before the treatment, and this is the weight after the treatment. And the question is to see which treatment is most effective. So in other words, which of the 3 treatments made the largest difference to the weight before and after the treatment, right? So let's see how we can do this, right? So paste it here. So let me call this just for short anorexia, right? All right, so I'll just read the data. Okay, now if you type names anorexia, it will show you the names of the columns that you just read, right? Okay, now, as I said a minute ago, second ago, I'm interested in the treatment, right? I'm interested in knowing the treatment that is most effective. So let me, just for short, let me call this treat, just for short name, okay? Now, I want to know the difference, between the weights before and after the treatment. So what I'm interested in is the following, and is the following, right? That is the difference in weight before, after the treatment, take away before the treatment. So this computes the difference in weight, right? So if you type this, you can see the differences in weight. Some of them are positive, some of them are negative, right? Now, I want to know which of the three treatments is most effective. So I need to consider the differences in weight for each treatment, right? So that's what I'm going to do now. I'm going to use the following command. Okay. Now, what this does is it computes, or it selects the weights, the differences in weight corresponding to treatment 1, and this selects the differences in weight corresponding to treatment 2, and this one selects the differences in weight corresponding to treatment 3. Now, as I said a couple of times already, I want to know which one is most effective, which of the three treatments is most effective. So one way to do that is to use the summary statistics command. As you can see from the summary statistics, the difference is largest for treatment number 3, because, as for example, the median is largest for treatment 3. The mean is largest for treatment 3. The third quartile is largest for treatment 3. And the maximum is largest for treatment 3. So hence, of the three treatments, the one that is most effective is treatment 3. Now, another way of observing this is to use the box plot. The box, as I said a few minutes ago, box plot is very useful when you have multiple groups, which is the case here, right? You have 3 different treatments, right? And there are 3 different boxes. So this box is for treatment 3, this box for treatment 2, this box for treatment 1. So as you can see, the differences in weight, the y-axis, are largest for treatment 3 and second largest for treatment 2 and smallest for treatment 1. Hence, treatment 3 is the most effective, treatment 2 is the second most effective, and treatment 1 is the least effective, right? So a box plot like this is very, very useful for, like, if you show it to a doctor or something, for example, he will be able to see immediately, like, which treatment is going to be most effective, right? So box plot is very, very useful. All right. So this completes exercise 3 and also the tutorial sheet. Any questions so far on what we did? I mean, anything that we did today on this tutorial, including the 3 exercises I've done. Guys, are you okay? Everything is okay? All right, good. All right, guys, have a good evening wherever you are. A couple of announcements. One is that the quiz number 2 is due tomorrow, UK time, 10 a.m. Right. So please, if you haven't done so already, please submit quiz 2 before 10 a.m. UK time tomorrow. right? And the second announcement is about the feedback form. The feedback form closes on Friday, that is the day after tomorrow. So if you haven't completed it, could you please, I would be really grateful if you could kindly complete it before Friday, right? If you haven't done so. Okay, guys, so I will post a copy of this video shortly. Give me about half an hour. I will post this video in YouTube and also on the university website. Okay, so you'll be able to see that. All right, guys. So have a great evening and keep safe. Okay.